So, good morning, everybody. I hope you're having a great day so far. I am Gaetano Panagia with Hamamatsu Photonics Europe, and today I want to talk about miniaturized UV visible spectrometers and how they enable real-time water quality monitoring. Let me start with a brief outline of my talk today. I will introduce the challenge of water quality monitoring. After that, I'll present about traditional methods and optical methods for water quality assessment. And then we'll dive into the difference between single and multi-wavelength analysis and what are the pros and cons of each method when measuring water quality. Finally, I want to introduce the new Hamamatsu UV spectrometer, which is opening up new possibilities for this market, specifically for its extremely compact design. But let's start from the challenge that water quality monitoring poses. There is 3.4 million people that die every year of waterborne disease. This is about the size of a city like Berlin. And nevertheless, 80% of wastewater goes back into water streams without any treatment. But there is a strive to change that. Two main reasons then to measure water quality. One is regulation. In fact, factories, they need to make sure that all pollutants are under control whenever water is being released back into water streams. And the other one is drinking water quality monitoring, because we all want that the water at our home is always as safe as possible, as good as possible. And we also need to react in case of accidents. We need to react immediately if there is any accident that poses a threat to our health through our water supply. So we need to measure the quality of our water. How do we do that? Traditionally, there is two main methods. One is chemical, which can be electrochemical analysis or titration. And the other one is biological, that uses bacteria to assess the quality of water. But these two methods, they have some drawbacks, some cons. In fact, you need to sample your water, ship the sample to a lab, so there is some time to results that can go from days up to weeks. And everybody wants real-time analysis nowadays. Second, you need, at the lab, you need bulky equipment, expensive equipment, and you need extremely specialized personnel that is not always available everywhere at any time. And finally, this process needs some reagents that can cause secondary pollution as well. But what is the alternative? So the alternative I want to present today is a physical method. It's called absorption spectroscopy. I'm sure many of you is familiar with the technique already, but let me introduce it for you. So you have a light source, a broadband light source, which generally emits a white light. Then you have a sample. And this sample absorbs some specific wavelengths of light and transmits some others. So analyzing the wavelengths that are transmitted and how much they are transmitted, we are able to understand what's the chemical composition in the sample, so we can understand what's the pollutants in water. And we do that using what's called Lambert-Beer's law, which depends on three main factors here. So one is the molar absorptivity, which is specific to each chemical present in the sample. And the other one is the path length, so how long the light has to travel through the sample before getting measured. And the third, which is one of the most important, is concentration. In fact, using optical analysis, we are not only able to assess if pollutants are present in our sample, but also we're able to detect how much of those pollutants is in there. This kind of analysis can be done in real time and can be done on-site, thanks to the compact spectrometers and the compact sensors that we have access to today. Second, there is no filtration needed. In many cases, especially when you use a broad spectrum of light, you can compensate for particles, so you don't need to filtrate your samples. And finally, we do not use any reagents, so the true process is completely environmentally safe, sorry. But what kind of parameters we can measure when we use optical analysis? Well, the parameters are the same that are used in general when you use those traditional methods. So you can measure total oxygen content, chemical oxygen demand, or the BOD, biochemical oxygen demand. You can measure the presence of disinfectant, and these are all parameters that are measured in the UV spectrum, here between 190 and about 400 nanometers. Then, if you also include the visible range here, you are also able to measure turbidity of water. And this helps when compensating from location to location variations. So extremely powerful method to measure water quality analysis. The simplest method that we can have, the simplest optical method that we can use is a single wavelength analysis. So what we do is we still have a broadband light, we still have the sample that transmits some of that light, but in here we have a bandpass filter which only lets through one specific wavelength, which is usually the wavelength that we want to analyze. For example, UV254 is one common parameter that we want to assess. And then you have a single photodiode here. And Hamamatsu Photonics offers single photodiodes for these kinds of applications. This can be used to measure total nitrogen content, COD, BOD, nitrate, and nitrate, but only singularly. This kind of method is extremely simple, as you can see, and it can get to an extremely compact footprint. But, there is a but, you can have a limited amount of information, just a single wavelength information, which causes limited accuracy. Finally, since we do not measure in the visible range, it is difficult to compensate for turbidity using software analysis. The most accurate way of measuring water quality using UV spectrometry is a multi-wavelength analysis. So we have our light transmitted from the sample. We direct this light towards a transmission grating that separates each wavelength, separates the broadband light in each wavelength component, and then each wavelength component is focused on a different pixel of a linear image sensor. This method gives us a lot of information on the water, several information at the same time. So comprehensive analysis, we can still achieve a compact footprint, and that's what I'm going to show you later with our new product here. We can achieve software particle compensation when we also include some part of the visible in the analysis. And finally, high accuracy, high repeatability, even location from location. And this is the device I'm here to present today. So this is how it looks like. It's not clear from this slide how small is it, but it's the size of a fingertip. So the longer side here is 20 millimeters. Extremely small. So I invite you to come over to our booth just beyond this wall, and you can also see how small is it with your eye. Traditionally, we cover the visible range, 380 to 850, great for colorimetry, so to measure, for example, the exact color of a car paint, to test LEDs, to test displays. But today, we are here to present a new spectrometer in the UV between 190 to 400 nanometers that can be used for water quality analysis. And Hamamatsu is, this product is completely manufactured by us because we have expertise in optical design, optical fabrication using MEMS process, and then we are market leader for sensors, image sensors for spectroscopy. So everything condensed in one module for easy of use. Here are the specs of this new product. We already talked about the spectral range. What is the resolution that you can achieve with this product? It is 5 nanometers in general. You achieve a good signal-to-noise ratio, great dynamic range. We already mentioned the compactness. You can see the size here. And then we also included an electronic shutter function so that you can coordinate light emission and detection in order to have a lock-in amplifier and lower the influence of noise in your measurement. Finally, these are extremely low power consumption devices that are designed to be integrated into handheld battery-powered devices. But we do not only offer spectral detectors, we are also traditionally offering UV lamps, specifically in this slide, xenon flash lamps. We have a wide selection of those. You can see several different form factors, several different trigger sockets or not without trigger sockets, several different watts available for any application. And they are perfect for water quality analysis, specifically those low power consumption ones that can also be integrated into handheld devices. And as you can see, the spectral range, the main emission of these UV lamps is in the UV, so between 200 and 400 nanometers, perfectly compatible with our spectrometer, with our newly introduced spectrometer. And here is a demo that we carry around that integrates our xenon flash lamps and our new UV spectrometer. So what we are measuring here is some pollutants in water. So we have nitrite, nitric acid, and BOD, so biochemical oxygen demand, dissolved in water. And here you can see the absorption peaks. They are all in the UV spectrum. And then we compared the measurement from our device here with a general benchtop spectrometer. So in this case, we are measuring several concentrations of anthracene. And you can see that the peaks that are measured with a large, expensive benchtop device are the same peaks that we can measure with our small and compact spectrometer. So really, this device enables real-time and on-site measurement when it comes to water quality assessment. It is, as you can see, is an analog device. So it's a chip that needs to be assembled on an evaluation board, on a general electronic board. So in order for you to test it, we provide some evaluation circuits that can be used for initial evaluation, but it can also taken as a sample, as an example for further developments in your system. And this is USB powered, just to show how low power consumption this device works with. Besides the xenon flash lamps that I introduced, we also offer deuterium lamps, as well useful for water analysis, because again, 200 nanometers to 400 nanometers is the emission spectrum. And these lamps are specifically chosen in general for their extremely high stability and long lifetime. But we do not only offer this UV spectrometer, we have a whole range of products that can be used for water analysis and beyond that. In fact, if you want to measure beyond UV and you want to go in the visible, then we offer also CMOS and CCD sensors, which are renowned for spectroscopy. So in case you want to assemble your own spectrometer, if you are an expert in optical design, you can purchase our CMOS and CCD optimized for spectroscopy. In fact, most of these sensors, they don't have a squared pixel, but they have a rectangular pixel to improve the light collection in spectroscopy application. And finally, if you want to dive further in the spectral range, up to 1700 nanometers, so in the near infrared, where, for example, total phosphorus or total nitrogen can be measured, you can also purchase gallium arsenide pin photodiodes or even image detectors. So generally, Hamamatsu can be considered a one-stop shop for water analysis technology. But not only for water analysis technology. I've taken a walk this morning in the show. I've seen so many great gas detectors. Well, this UV spectrometer that I'm talking about today, it can also be used for gas sensing. Specifically, we have sold into applications like continuous emission monitoring for large ships. There is stringent regulations for ships, large ships that needs to access harbors. They need to certify their emissions of NOx gases, SO2 gases, and ammonia. Well, using UV visible spectroscopy, you can also measure and quantify the amount of these gases if you deploy one of these spectrometers in the chimneys of these large ships. So just a takeaway message from my talk today. UV spectroscopy is enabling real-time water quality monitoring. So while before the size of these devices would not allow for this technology to be deployed directly on site, now we can do it using these compact devices. Using UV and visible wavelengths, we can detect several parameters that are traditionally measured in a lab with expensive and bulky equipment. The new spectrometer can change really the market when it comes to water quality monitoring, and this is a market that is happening right now. And then besides our spectral detectors, we also offer UV lamps to complete our offer for any kind of application which is related to water quality and beyond that. So come visit our booth. We are just back there at booth 314 to see the size of these spectrometers and all the other amazing products that Hamamatsu has to offer. So thank you very much, and I'll be happy to take any questions you have.